Hey guys, welcome to eMaths and let's do some maths for fun. In previous video, we have covered the concept of trigonometric ratio and proved all three Pythagorean identities. In this video, I will be proving all three compound angle formula. Are you ready? Start! Today, asine, acos, and atan will play on the Cartesian plane. To make sure that they don't get lost on the Cartesian plane, they paint the origin with rainbow color. Suddenly, the rainbow shot out a laser beam, and the beam hit a bird. The bird falls down to x-axis. Asine, acos, and atan are very happy because it is a right angle triangle. Theta then fly from the sky because she is an angel. An angle. If theta is here, then this side will be adjacent, this side will be opposite, and this side will be hypotenuse. Supposingly the bird can fly in a circle if it is not shot down by the beam. So we call this a unit circle. By definition, a unit circle is a circle with center at the origin and always have a radius of 1 unit, because the limit distance that the beam can reach is 1 unit. Just kidding. It's actually because the number 1 is called the unit in mathematics, like unit vector, unit time. In this case, once the hypotenuse has a fixed length of r equal to 1, then the values of trig ratio will only depends on x and y. Since multiplying or dividing by r equal to 1 won't change anything. Like you can see in this animation, the hypotenuse of the right triangle is always the same as the radius of unit circle, which is 1. How is that helpful? For the unit circle we had earlier, we know that radius equals to 1, so hypotenuse of this triangle also 1. Let's say the original coordinate of the bird is x, y. Automatically, opposite will be equals to y, and adjacent will be equals to x. Still remember toa ka so? If atan wants to eat the bird, he has to take opposite over adjacent, which is y over x. How about acos? He needs adjacent over hypotenuse, which is x over 1, and it's just x. Then for asine, opposite over hypotenuse, y over 1 equals to y. As x equals to cos theta and y equal to sin theta, I will just label this point as cos theta, sin theta. And this is just for quadrant 1. Because we know that basic trigonometric ratios are only for right triangles. If we have an obtuse angle in the triangle, we cannot have another right angle in the triangle, right? If not, we will have a triangle with internal angle more than 180. That is impossible in 2 dimensions, but actually possible in 3D. So this time, we will let alpha be the obtuse angle. And by chance, alpha plus theta from earlier is 180 degrees. So that I can make out this reference triangle. And this angle here will be theta because it's 180 minus alpha, right? Because we want hypotenuse to be 1. The coordinate of this point will then be negative x, y. As you can see, x is in negative zone, but y is still in positive zone, which is above 0. Still toa kaso, tangent equals to O over A equals to y over negative x equals to negative y over x. Cosine A over h, negative x over 1, negative x. Sine O over h equals to y over 1 equals to y. We now combine what we got from quadrant 1 and quadrant 2. We have this for quadrant 1 and this for quadrant 2. Note that the angles are in alpha for quadrant 2. From observation, we can see that tangent alpha is equals to negative tangent theta. Cos alpha also becomes negative, but sin alpha equals to sin theta. This is because trigonometric ratio are ratio of any 2 sides of the right triangle. As long as either one side taken is negative, the ratio will be negative. In this case, both y and 1 are still positive. That is why the value of sin theta equals to sin alpha, which is still positive. As we defined earlier, alpha plus theta equals to 180 degrees. So alpha equals to 180 minus theta. Substitute this into the ratio we got. Tangent 180 minus theta equals to negative tangent theta. Cosine 180 minus theta equals to negative cosine theta. And sine 180 minus theta equals to sine theta. Remember this small conclusion we made in quadrant 2. We will need this letter. For quadrant 3 and quadrant 4, I don't think I have to explain it one by one, right? Just that alpha is growing bigger and bigger. We still use theta as reference angle in every quadrant because she's cute, right? I mean, acute. So this will be our reference triangle. Hypotenuse equals to radius equals to 1. For quadrant 3, this point will be negative x, negative y. For quadrant 4, this point will be x, negative y. Then what about alpha? How is she related to theta? For quadrant 3, we can see that 180 plus theta equals to alpha. For quadrant 4, 360 minus theta equals to alpha. We now do the same thing for quadrant 3 and quadrant 4. But I don't want alpha because it's not cute enough. I want to express all of them in theta. Alright, so to sum it up, just look at this chart. If the angle landed on quadrant 1, O ratio will be positive. Quadrant 2, only sine is positive. Quadrant 3, only tangent is positive. And quadrant 4, only cosine is positive. In short, we have proven all science teacher crazy. When are we supposed to prove that? Isn't it already a fact? Moving on. Finally, we get into the topic, compound angle formula. But before we begin, we have to know what is a compound angle. It's actually an algebraic sum or differences of two or more angles. For example, I want to find sine A plus B or cos alpha minus beta. You can just say, hey, if A plus B equals to C, then why not just take sine C? But what if we have something like this? Don't scared. I will use a unit circle to explain how we get there. First, draw a line from the origin, let this point be P, with coordinate A, B, connect it perpendicular to x-axis, let this point be S, with coordinate A, 0. Now we have a right triangle. And I will label this green angle as beta. Now simply put another point on the circle. Let's call it Q with coordinate negative C, D. Connect it to the origin. This pink angle here is our alpha. If we draw a right triangle here, let's call this R, negative C, 0. This angle will be 180 minus alpha. Lastly, connect point P and Q together. So this angle will be alpha minus beta. Now we have our very beautiful mastermind. Oh my god, it looks so complicated, right? Don't worry, be happy. We will analyze triangle by triangle. We'll start with the yellow triangle OPS. Since x coordinate of P is A, so base equals to A, height equals to y coordinate which is B, hypotenuse equals to 1 because it is a unit circle. Apply Toa Ka So. Sine beta will be B over 1 which is B, cos beta equals to A over 1 which is A. For pink triangle OQR, base is negative C, height is D, hypotenuse is 1. Toa Ka So again, since 180 minus alpha equals to D, cos 180 minus alpha equals to negative C. But 180 minus alpha is still complicated, right? Remember what we learned in quadrant 2? We can simplify this and write sin alpha equals to D and cos alpha equals to C. Now we have expressed all A, B, C, D in alpha and beta, and this is what we need later. Okay, refresh our mind for a while, recall back something easy, the distance formula that we learned in coordinate geometry. Distance equals to square root of y2 minus y1 square plus x2 minus x1 square. In our masterpiece from earlier, distance PQ equals to square root of c minus a square plus d minus b square. To make our life easy, I will square both sides. And look at this cute ABCD.
Kawaii Koto.
This is what we got from earlier. I arranged it nicely already. Expand the brackets, we get this long equation. I'm running out of space already. Okay, this long equation, we just have to rearrange it and factor. Look at these two brackets. It's so familiar, right? In the last video, we just proved that sin square A plus cos square A equals to 1. In this case, it will just be alpha and beta. So 1 plus 1 minus 2, cos alpha, cos beta minus sin alpha, sin beta. 1 plus 1 is 2. And finally, we get this. Almost there, right? You think we are done? No, this is just equation 1. Oh my god, this is so tedious. I want to take a break again. In the meantime, let's prove Al-Kashi Law of Cosine, because I'm a fan of Kakashi. Consider a random triangle ABC. Label the length of triangles like how we always do. Draw a line perpendicular to BC from A to get the height of the triangle. Label this point as D, this angle as theta, lastly BD as x, so that DC will be A minus x. For triangle ABD, by Pythagorean theorem, c squared equals to x squared plus h squared. Rearrange it. H squared equals to c squared minus c squared. We call this our blue equation. Also, for triangle ABD, cos theta equals to x over c, so x equals to c cos theta. Let this be red equation. Then for triangle ADC, apply Pythagorean theorem, b squared equals to h squared plus bracket a minus x squared. Expand the bracket, sub in blue equation and red equation. X squared and negative x squared can cancel out. Rearrange, we get b squared equals to a squared plus c squared minus 2ac cos theta. And this is Al-Kashi Law of Cosine. That's all for break time. Come back to our masterpiece. The only triangle we haven't touched on is this triangle OPQ. We now apply Al-Kashi Law of Cosine. We have PQ squared equals to OQ squared plus OP squared minus 2OQ OP cos alpha minus beta. OQ and OP are radius of the circle, so it's equals to 1. Simplify, we get PQ squared equals to 2 minus 2 cos alpha minus beta. And this is our equation 2. Bring back equation 1 from earlier. Compare equation 1 with equation 2, which is this part in yellow. We will get this. Algebraically, if it is alpha plus beta on left hand side, then it will be minus on right hand side. Anyway, this is the first compound angle formula that we have proved today. Moving on, watch an animation to relax a bit. From this animation, we can see that sine and cosine complement each other by 90 degrees. Another proof is, consider a right triangle ABC. Since total internal angle of triangle is 180 degrees. So alpha plus beta plus 90 equals to 180. Simplify, we get alpha equals to 90 minus beta, or beta equals to 90 minus alpha. We know that sine alpha equals to AB over AC, which is equals to cos beta. And beta is 90 minus alpha. While cos alpha equals to BC over AC, which is the same as sine beta, and equals to sine 90 minus alpha. The concept here is, when we take sine theta is equals to cos 90 minus theta, while cos theta equals to sine 90 minus theta. This is a very important concept for later. With that concept, sine alpha minus beta equals to cos 90 minus bracket alpha minus beta. Expand the bracket, we get cos 90 minus alpha plus beta. We separate the compound angle like this. We can apply the first formula that we have proved just now. Again, sine and cosine are related by 90. Finally, we have sine alpha minus beta equals to sine alpha cos beta minus sine beta cos alpha. With this in the set, we have proved the second one. This is not the only way to prove this formula. We can also prove it geometrically. Read out by yourself. The link is in the description of this video. Finally, we are here. After first two formula, this will be so much easier. We know that tangent theta equals to sine theta over cos theta. For now, we change theta to alpha plus beta, which is this, and do this, so that we can cut. This part obviously is tangent alpha, right? And this part is tangent beta. This is just 1, and this is tangent alpha, tangent beta. Finally, we got the formula. Cheat a bit. And we are done. Compound angle formula, mission complete. I will leave double angle formula for the next video. Today's progress, another 1/3. Thank you for watching. If you like this series, see you guys in the next video.